morning, pilot teachers and students. Good morning, class. Okay, thank you very much. Right, we can. That is our topic for today's discussion, and it's on motion crafts. Right. Basically, when we are drawing up crafts, these crafts give us a very important information about a motion of an object. All right. So there are different types of crafts that we studied, especially in kinematics. Can you give me one, or can you name me one of those crafts that we had looked at?
Velocity against time.
Velocity time graph, and what was the others? Yeah.
Displacement time graph.
Okay, displacement time graph, and then you also have acceleration time graph. Right, there are many graphs that we studied, but especially when you have to look at these, there are different features of each of those graphs. All right, looking at how you draw the graph and how, let's say, the steepness of the graph will tell you about a quantity, or let's say the size of a quantity that you will be measuring. For example, in a velocity time graph, the area under the graph will give you the velocity, rather the displacement. All right, the slope or the steepness of the graph will tell you the acceleration. All right, acceleration can be in two ways. When it's in positive direction, that is when the graph will be above. Okay, when you are drawing that below the horizontal line, when you have numbers or the graph that is downwards, then you have a value which is negative for acceleration. Also, if you are also finding the displacement would be the area, and you will have to minus especially the displacement if it is in the opposite direction. But if it is only in one direction, then it will be always positive. And for distance, there's nothing to do with the direction. So you start working out the area, and that gives you the total distance. And if you want to find the average velocity, then it is the total displacement over the total time taken. If it is the average speed, it is the total distance over the total time taken. So in this lesson, we just go through and have a look at each of the motion graphs. The first one is on displacement time graph. All right, by looking at this graph, who can tell me, okay, this is a displacement time graph. Right, looking at the steepness of the graph, or in other words, the graph actually tells you the area there will tell you. Right, it gives you the, then what does the slope of that graph tell you of?
Uniform velocity.
All right, the slope will be and the velocity. But if it is upwards in that, okay, probably this one is a constant or uniform velocity, right? Because it is increasing every time. And if you have to calculate the slope at any one of these points, it will be the same throughout. Therefore, we can say that it has the object has a constant velocity. Right? Sometimes you will find that the different types of displacement time graph. Right? Let's say this is number one, and you have the time in that. Okay, if you were given something like this, then probably you can say that the object was speeding up at this point, okay, because the speed will be constant. And then after this point or time, you will have this in which the object was at rest. There was no distance covered, but the time was actually increasing. Therefore, we can say that the object was at rest at this point. Okay. Even if you were given something like this, okay, let's say this is A and this is B. Right, this one shows that the object it's accelerating. Okay, meaning that it is changing in speed, right? It is changing speed every time. Right, at this point, if you have to calculate the slope at this point, there will be different value unless you throw a line of best fit into all of these points. So this kind of graph shows you that the acceleration or the object is actually accelerating. Right, this one, the speed is constant, meaning that it is not accelerating. And at this point, it is at rest, and then the speed is constant again. So that is some of the graphs that we will be going through in our discussion today. Right. Number one is that graph. As you can see, some of the main points on that would be the velocity is constant, the gradient gives us the velocity, and it also shows the direction of the motion. Okay, that is from graph number one. All right, you can just make a sketch of it, the diagram, and have those points beside that diagram. Okay, we'll move on to the second graph. Again, also on displacement time graph. You said there was no change in velocity, so that means the object was at rest. Okay, because the time is increasing at displacement, which is 4, the object was at rest. All right, so just sketch the diagram quickly. You can have those vertical axis as the displacement and the horizontal axis having the time. points on that graph. Okay, on to graph number 2, the third one. Right, on to the main points now. Right, to the next. right, if you can look up, I'll just explain to you the, okay, this is another displacement time graph. Right, this is where you have the object which is changing speed at different points. In here, between displacement which is 0 and 5 meters, and you have the constant speed up here, or rather displacement. Okay, velocity is constant, and then from there after 5, or let's say 4 meters, the object was at rest, and you have the initial velocity which is at this point. That is when the object was, so you can always calculate after the motion of an object at rest, then you can always calculate the initial velocity, okay, after at rest. So this is the slope that you will be calculating to find out the velocity of this object. Right, where you find the object which is, let's say the graph which is more steep, right, as you can see at B, is more steeper than the others. So you can simply say that at this point, the object or the motion of an object was at very high speed. Okay, in here the speed was less than that. This, so this is very high velocity. All right, so after you sketch that graph, I will give you the main points on that. The object is at rest in A and the object is at B. Okay, it is accelerating. In other words, there is a change in velocity at different points. Next. All right, this is another graph or another kind of graph for motion, and that is on acceleration or acceleration time graph. Acceleration on the vertical axis, and then you have the time. You can take this information, especially after getting the acceleration of an object. It can be done, or this information on acceleration time graph can be transferred from or taken from the velocity time graph, or let's say speed time graph. So from this you can be able to plot out these. So for that you can see that the object was at rest. The total time for the travel of that was about 12 seconds, and within that 12 seconds, you find that the acceleration was greater at time equals 4 seconds, because it is about 5 meters per second square. And if you have to look at the acceleration between 4 and 5 seconds, there is no acceleration. So that shows you that the object was actually at rest, or probably it has a constant velocity. And in here you find that the acceleration was negative, or having some kind of value which is negative. So you can assume that the acceleration or the object is actually decelerating or is retarding. So that is the acceleration time graph. Just sketch that quickly, and then I'll give you the main points of that. craft. I will now show you the main points. All right, this is the velocity time craft. Can you just take that or sketch that? Draw a line across this one, not this one. All right, we shall move on. Okay. This will be your activity. I want you to copy this information quickly. This is only one activity based on graphs. Now, this after you have copied this information, that information I will be giving you the question, and the question is to change this information into a distance time graph. Okay, this is displacement time. This information given on that displacement time should be changed into a distance time graph. So quickly sketch that information. Some of you who are actually at the back end cannot see it properly. Right, that time is from 0 to 46, and only negative value would be 0, -2, -4, and -6. And you have the time which is on the horizontal axis, that is from 0, and then you have 5, 10, 15, 20. Right, this will be up to 5, and it goes over to 10, where the velocity is, or the object's motion is at rest, and then it changes from there down to 15 will be 0, and this will be at 5. So that information, quickly sketch that, and then your question will be coming after this. B5, go to 10. To 10, from 10 it comes right down. Doesn't matter whether you start from 10. No, up. Yeah, that's it from 10. Right down to 20. We have this one B5, okay. Sketch. Move here to 10. Then from 10, 15. This one will be across 5. Let me see. Yeah, okay. By now you should have finished sketching that, and here comes your question. to convert the graph into a distance time graph. And secondly, what is the cyclist speed at time equals 4 seconds and time equals to 12 seconds. So after you have done that, converting that into a distance time graph, using that information you can calculate the speed at time equals 4 seconds and time equals 12 seconds. All right, you will only have to copy the question, and then you can do this activity for homework, and we will discuss the answer to that problem in our next lesson. So you can only copy those. Are there any questions? All right, quickly to sum up the topic, graph arcane will help us to understand the motion of an object. Right, there are different features of a graph. Let's say in a velocity time graph, you'll be given the acceleration and displacement. And also in a displacement and distance time graph, you will be given the slope as the speed of the graph. If it is a steeper graph, that shows you that it is speeding up. If it is less steep, probably it is not speeding up. So those are some of the features that you can recognize or find out from a graph. And you can also convert information from one graph to for another. For example, if you were to use the information on a velocity time graph, you can actually get the displacement, or you can actually use an acceleration to plot a graph of acceleration against time. Or sometimes if you are given a displacement time graph, you can also convert this displacement time graph to distance time graph and then find the speed at different points. Or if you are given a speed time graph, you can also convert that speed time graph into a displacement and then find the velocity. So different features of the graph will give you different information of the graph. All right, so that brings us to the end of the lesson, and our key phrase will be motion graphs. Good afternoon, pilot teachers and students, and good afternoon, model class. Okay, thank you very much. You may sit down.